Welcome to BYJU'S Exam Prep, the comprehensive learning preparation app for your competitive examinations. I welcome all for this particular session of Nielit 2023. And in this particular session, we take up the following problems on the following topic, that is greedy as well as dynamic programming from algorithms. Okay. So without wasting much of your time, let us start the session. And before that, a small intro about me. Myself, Sridhar Dhulipala, having 20 plus years of teaching experience, and I'm associated with BYJU'S from past 2 years. And you can join my Telegram group CS_Sridhar to get regular updates about my classes. You can also join my Facebook as well as Instagram pages. Okay, so that is about me, my dear friends. And today's topic is greedy and dynamic programming. Problems on greedy and dynamic programming required for Nielit examination. As already discussed earlier also, my dear friends, the questions for this particular Nielit examinations, logically they may be strong, but because the number of questions to be completed in the time, 120 questions we have to complete in 3 hours. Okay, so the time for each question will be less. So obviously, uh, the question complexity will not be as difficult as GATE examination. That you need to understand. First point. So first question, under greedy algorithms, this problem on Huffman coding. See, the basic idea of Huffman coding, you all know it. What is Huffman coding, sir? So we are having some letters, or in a particular what do you call that, frequency of letters is given to you. Maybe you want to send particular data. In that particular data, we have frequency of letters given to you. As it is, if you send, it may take more time, and if you use fixed length code, it will take more space. So obviously, to reduce the space, that is, Huffman coding is a compression algorithm. What it will do, it will compress the data by difference very efficiently. Okay, so we call it as lossless data compression algorithm. Am I clear? So let us see what this particular algorithm do for this particular uh, data frequencies given, or character frequencies given. See, here we are having, in the particular data we are having, these are the letters we are using and their respective frequencies. Now we need to create Huffman coding for this. Namaskaram, sir. How are you? Hi, Abdul Momin and Manishankar Tiwari. How are you? Hope you are doing well. All of you are doing well. Nice to see you back. So in Huffman coding, once the letters and their frequencies are given, what you need to do is you need to sort them. Sort. And luckily, the given letters and their frequencies, we have to arrange the letters according to their non-decreasing order of frequencies. Non-decreasing means increasing only with equal fellows together. Am I clear? So let us solve this problem. The logic is very simple, sir. Once you sort, select the files with least frequency, you merge them. See, actually what we do is we initially create, for example, here how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8 letters. You create 8 trees. Means you are going to create a forest where we are having 8 trees, where each tree is having a single node. That is it. Now what we are going to do is we are going to select the nodes with least frequency and we merge them. Okay, and we are going to create an internal node whose left subtree is the one with smallest frequency, right subtree or right node or right child is the node with next smallest frequency. See, when you are having equal fellows, you can keep them together. That is it. So what I am going to do is I take A, this is having frequency 1, this is having frequency 1. So I'll just keep it as it is. So we merge them. So the root node will have frequency which is equal to sum of these two frequencies. That is 1 plus 1, which is equal to 2. Okay. So this is corresponding to A and this is corresponding to B, my dear friends. See that leaf nodes generally they keep it in square boxes. I don't want to use that much energy. So I'll just keep them open. Leaf nodes, I just keep them open. Am I clear? It will save our time. Hi Babu Sham. Very good. Next, what you are going to do? This particular node we are going to insert again. Okay, these two are gone. Now we are going to insert it in the order, the new node which is created. Actually, you are going to create the priority queue, my dear friends, priority queue of the nodes, and this new node will be inserted in that particular priority queue. So obviously next fellow is 2. See, I am writing leaf nodes as 2, just number, whereas the created nodes I am writing in a circle. So next node, this 2 fellow will go here. This is where it will go. So that fellow will be next smallest. You merge them. So when you merge them, whatever the frequency of the root node, 2 plus 2, for that is 4. And this is gone and this is also gone. 4 will go here. And that is a created node. I just call them as created nodes. Then what happens? Next smallest is 3 and this 4 fellow. Merge them. And the root node frequency will be 3 plus 4, which is equal to 7. And where it will go, sir? So this is gone, this is gone. Then 7 will go here, which is a created node. 5 and 7. You merge them. 5 plus 7 is 12. Very good. Super. Perfect. So where this 12 will go, sir? 5 is gone, 7 is gone. 8, 12 will go here. So 8 is next smallest, 12 is the next one. 8 and 12, when you merge them, it is 20. Where this 20 fellow will go? This is gone, this is gone. 20 fellow will go here. So 13 and 20. You merge them, it becomes 33. So where 33 will go? These two are gone, 33 will be here. And obviously, these are the last two frequencies, you merge them. So obviously, 21 is the left part and right part is the created fellow, that is 33. And when you merge them, the root node frequency will be 54. Now you can construct the entire tree, my dear friends. Actually, every time people will create that entire tree, so many trees will be constructed, but I am not doing it. I am just keeping that created node. Using that, I understand that, you know, this particular created node is created from what nodes. So that can be constructed now. So I construct the entire tree now. 33 is constructed from what? The leaf node 30. And of course, this 20 is a created node. Please be careful. 20 is created from leaf node 8 and the created node 12. 12 is created from leaf node 5 and the internal node we call them 7. Then 7 is created with leaf node 2 and the internal node 2, and 2 is created with both the leaf nodes 1. Very good, super CS Vision, ER Chandan Kumar, super. So that is your Huffman tree, you can call it. This is your Huffman tree, my dear friends. Now you can create the coding. How to create the code? See, generally for the left edge we give the label 0 and right edge we are going to give the label 1. So this is 0, this is 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now this 21 correspond to H, this 13 correspond to G, 8 correspond to F, and 5 correspond to E, and D is this 2. I think 3 is there, no? Oh, 7 is made up of 3 and 4. Oh, somewhere something is wrong. Wow, super. Now let us complete this story. Sorry. There was a mistake, printing error. 7 is made up of 3 and 4. 4 is made up of both 2's. Where one fellow is leaf, the other one is created. It is made up of both ones. No problem. Luckily, it is not troubling us much. So here it is 0, 1, 0, 1, 0, 1. So 3 is what? 3 is that D, and this 2, leaf node 2 is C, and this A left one is A1, B1. So now you can see the code for each and every letter, my dear friends. So from root to leaf, the edges labels, if you write down, that will be the Huffman code for that particular letter. So for H, the Huffman code would be, for H, the Huffman code would be 0. And for G, the Huffman code is 10. And for F, it is 110. For E, it is 1110. D, it is 410. C, it is 510. And A, it is 610. And B, it is 7 ones. Is it 7? Yeah, 6. Yeah, 7 ones. 4, 5, 6, 7. Now you know code for each and every letter. Now, this particular coding can be used to decode also, because they are called variable length prefix codes. Actually, they should be called as prefix free codes. No code word is prefix of any other code word. Okay, so with that we can easily understand if a particular code word is given, you can easily decode that. So let us see this particular code which is given: 111 0, again 010 110. Now if you observe how to decode it, is there any fellow with one code? Is there any label with code 1? No. 11? No. 111? No. 1110? Yes. 1110, that is E. Done. Next, is there anyone with 0? S, that is H. Is there anyone with code 1? No. 10S, immediately write down 10 is G. Is there anyone with code 1? No. 11? No. 110S. 110 is F. It is very simple to identify the code. Many people already answered. Very good, Nana. Sham, super, wonderful, perfect, excellent. Right. अगला समस्या आपके स्क्रीन पर. And Huffman coding is one of the easiest problem. Okay, it's very simple to solve the problem. And if you want to find number of bits required, you just need to multiply the code length with the frequency. Okay, so if you want to know number of bits required, that is one more question which they can ask you to encode the entire file. So you can do what, sir? You can multiply the depth with depth is nothing but the code length. Code length is depth only. Here code length is depth. Depth multiplied with frequency. Di into Fi, where I varies from 1 to n. So that will give you the number of bits required. Sometimes they also ask you average number of bits required. That also you can calculate, sir. What is average number of bits required, my dear friends? The average number of bits required would be what you need to do? Total bits required divided by total frequency. See, these are the possible questions which they can ask you under this Huffman coding, my dear friends. They can ask you number of bits required या तो average number of bits required. See, sometimes they'll give you probabilities. Instead of giving the frequencies, they'll give you probabilities. In that case, directly you get average number of bits required. So directly this formula will give you average number of bits required, my dear friends. That need to be taken care. See, if you understand, any question can be answered. That's it. That is about your Huffman coding, my dear friends. Super. Of course, this question was only this one. He asked HGF. This is what he asked. For this, what is the characters corresponding to this code? That we already answered long back. Very long back. So then, the next one, it is based on optimal merge pattern. Actually, the procedure for optimal merge pattern as well as Huffman coding are one and the same. But here problem is slightly different. What happens here is we are having files of varying lengths or different lengths. We want to merge them, okay, in a sorted order so that the number of record moves will be decreased. Am I clear? So that is the main aim of this particular problem. Here also the story is very simple, my dear friends. First, what you need to do is you arrange them in a sorted order. You arrange these files, okay, that is files in the sense each file is having some records, like 1 record, 2 records, 4 records. So you arrange the files according to non-decreasing order of their lengths. File length in the sense, file length here we can consider it as number of records in the file. Here you can take it as file length as number of records in the file. Number of records in the file. So first what we need to do is arrange the files in non-decreasing. See, non-decreasing means increasing order of their lengths. That is one very interesting question, my dear friends. Okay, so first let us arrange them. Same story. The procedure would be similar to that of your Huffman coding problem. First one, file length 1, then it is 2, then it is 3, 4, there are 2 5s, then it is 10, 2 10s are there, 15, 20. If anything is missing, please let me know. 1 2 3 4 5, 5 double 10 15 20, 10 files, okay, with the record lengths are given. Same story, sir. Select 2 files with smaller length. Okay, actually what we are going to do is, initially we create 10 trees with single nodes, then we take the 2 small trees with the small nodes or small keys or small values. Okay, then what you are going to do is, you are going to create a new tree with this with one fellow as the left child and the other fellow as the right child. Suppose if it is already a tree, one fellow has the left subtree and the other fellow has right subtree. See here, when you talk about the key, we are talking about the value at the root. That is what we can call it as value at that particular node. Am I clear? Or value of that particular tree. Even if it is a tree, we are going to consider the value at the root, or the key value at the root node is considered as the key value of that particular tree here. That's it. Then what you are going to do? 1 and 2 you are going to take, you merge them. 3 is the created node, these 2 are gone, the 3 will go here, the created one. So now this 3 and this created 3 merged to form 6. So 6 will go here. So this 3 and 3 are gone. Next 4 and 5 will come. Both are leaf nodes and they are merged to form 9. And the 9 fellow again goes after 6. So 4, 5 gone, and one more 5 is there and 6 is there. 6 is a created one. 5 plus 6 is 11. 5 plus 6 is 11. Then 11 should go where? After 10. So then 5, 6 gone, 9 is there. 9 and 10 are merged to form 19. So this 9 and 10 are gone. 19 will go after 15. Next we are having 10 and 11. 10 leaf node, 11 internal node, 10 plus 11 which is 21 merged. 21 goes to the end. Now 10 and 11 are gone. Now 15 and 19. 15 is leaf node, 19 is internal node. They are merged to form 34. That is wonderful. Shyam Babu, super. Wonderful. Perfect. Excellent. So that is 34. 34 will go here. 15, 19 gone. Now 20, 21 forms 41. 41 should go here. Now 20, 21 gone. Last final is 34 and 41. 34 and 41 is the final. Final two left and right subtrees, and they are merged. And how they are merged, sir? You are going to get a new root node whose key value is nothing but sum of these two frequencies. That is 75. Is there any mistake? Please let me know, sir. Calculation errors are there? Please let me know. Hopefully there are no calculation errors. If any, please let me know. Up to here everything is perfect. All of you able to follow? Okay. Now how 34 is made, sir? 34 is made up of leaf node 15 and the internal 19, and 19 is made up of internal node 9 and leaf node 10. 9 is made up of both leaf nodes 4 and 5. Then 41 is made up of leaf node 20 and internal node 21. 21 is made up of leaf node 10 and internal node 11. 11 is made up of leaf node 5 and internal node 6. 6 is made up of leaf node 3 and internal node 3. 3 is made up of both the leaf nodes 1 and 2. And that is your, okay, optimal or binary tree required for the optimal merge pattern. And it is similar to that of your Huffman tree, my dear friends. The binary tree only. Ultimately, it is a binary tree. Now you want to find number of record moves. Total number of record moves you want to find. Total number of record moves. Thank you, sir. So then what you can do, perfect. So you can just do the same thing, depth multiplied with the lengths of the records. The record and depth. Same formula you can use it. or you can add up all the internal node values. If you add also, you'll get the same answer. If you add up all the internal node values, that also will give you the same answer, that is number of record moves, my dear friends. So that is nothing but, you can say 15 into 2, 1 2 3 4, 4 into 4, 5 into 4, then 10 into 3, then 20 into 2, 20 into 2, then 10 into 3, 5 into 4, 3 into 5, 1 into 6, 2 into 6. And that will give you the answer, which is 219. Perfecto, perfecto. Super, super. Huh? Wonderful, super, excellent, bravo. Got it? Great, great. And that is the answer for number of record moves. So he asked number of record moves, that should be 290. The number of record moves, if he asks, that would be the answer. Clear? Now next problem. This is a very interesting problem. Hm is equal to k for m is equal to 0. Okay. So let me write Hm is equal to 0 or k for m is equal to 0, and it is equal to 1 for m is equal to 1. Then it is equal to 2 into, 2 into Hm minus 1. Array yaar. Plus 4 into Hm minus 2 for m greater than or equal to 2. See, it is given that H4 is equal to 88. Then you have to tell what is the value of k. That is the question. You can try that, sir. Of course, one method is 2. Very good. 2, 2, 2. Substituted and verified. Yeah, any other method. Substituted. Yeah, any other method you followed. Or you already know the question. That is very bad. Remembering the answer is not a good thing. Okay, back substitution. Okay, so H4 you substituted and you got that particular answer. See here, one thing we can do, sir. Back substitution is also a good idea. But one more thing which we can do is, see, whenever you are having excessive recursion, we can use the table. This is what you call it as memoization, and that is exactly the rule which helps us in solving dynamic programming or problems using dynamic programming approach. That is, whenever you are having overlapping subproblems, you are going to use the dynamic programming approach. So of course I am going to give you this method. Please see this HM. So here m is equal to 0, it is k. M is equal to 1, it is 1. For m is equal to 2 onwards, it is 2 times Hm minus 1 and 4 times Hm minus 2. That is 2 times of this plus 4 times of this. That is 2 plus 4k. Is that clear? 2 times of this value, 4 times of this value. Now for 3, what is the answer, sir? For 3, what is the answer? For 3, it is 2 times of this. 2 times of this means 4 plus 8k, and 4 times of this, that is 4. That is 8 plus 8k is this answer. Whereas this fellow, for 4, what is the answer? 2 times of this, that is 2816 plus 2816k, plus 4 times of this, that is 4 to 8 plus 4 4 16. Okay, wonderful. So that would be 32k plus 16 plus 8 24, and this value is given as 88. So it is 32k plus 24 is equal to 88. So what is the value of k? Of course it is 2. Okay, so it would be 64. So k will be 64 by 2. 1. So this is a good technique you can use whenever there is a excessive recursion. Whenever there is an excessive recursion, you can use this particular approach, and that is what exactly we call it as dynamic programming formulation. See, in dynamic programming, what we do, sir? We store and reuse it. Of course, some people tried with the back substitution, that is also fine. Like they might have done this like H4 is equal to 2H3 plus 4H2, and it is 2H3 means 2 into H2 plus 4 into H1, 4 into H1, 2 into H1 plus 4 into H0, and that they might have used this particular 4H2 plus 8H1 plus 8H1 plus 4H0, whereas this H2 again will be, you have to substitute. H2 is nothing but 2H1 plus 4H0, and it is 16H1 plus 4H0. So using this approach, I think you might have solved it. That is also fine, sir. But you do repetition work in this. You do repetition work because H2 is calculating here. Here also you are calculating H2. The same H2 is repeated 2 times. The same H2 is repeated 2 times. If I give H6, then you will understand actual difficulty of this method than the method which we used. Am I clear? So I want all of you to try the same problem for H6 value. Suppose here you already know H6 value. First find it. By reverse process, try to find the value of K. Okay, that can be done. Nice. Super. Sham Babu always perfect. Chandan Kumar also do well. What about the others? Huh? There are some other people. Why you are not coming regularly to classes? Not informing you. I think I am informing in my Telegram group. 4 matrices M1, M2, M3, M4 and M5 of dimensions P by Q, Q by R, R by S, S by T, T by U respectively can be multiplied in several ways with a different number of total scalar multiplications. P value given 10, Q value 100, R value 5, S value 50, T value 15, U value 1. Then total number of orderings that are possible to compute M1, M2, M3, M4 and M5 equal to. So here the question is the number of orders in which you can multiply them. Number of multiplication orders to multiply 5 matrices. That is the question. Number of multiplication. Yes, matrix chain multiplication. Multiplication orders possible to multiply 5 matrices. Babu, don't do matrix chain multiplication. Hear the question carefully. It is not about the answer. It is about how many orders you can multiply the matrices. The number of matrix multiplication orders possible for n plus 1 matrices is given by Catalan number Cn. See, number of multiplication orders possible to multiply n plus 1 matrices is given by catalan number Cn, which is 1 by n plus 1 2n Cn. Here I just ask this answer. I am not asking matrix multiplications. How many multiplications are required? I am just asking orderings possible. It is not about minimum number of multiplications required. Read the question carefully. It is not about minimum number of multiplications required. It is about if you are having 5 matrices without changing the order of matrices, how many multiplication orders are possible? And that is given by the formula for n plus 1 matrices. That is given by the formula Catalan number, which is Cn. C4. So answer for this problem is C4. What is C4? You need to tell me. What is C4? Catalan number. C11, C22, C35, C4, 14, C5, 42. Minimum at least first 5 Catalan numbers we should know. That is good for health. Super. C4 is 14. Super, Shyam. What about Chandan? What happened, Nana? Not answering. See, don't know, no problem. Just substitute. Na? Here n value you have to substitute, sir. 1 by n is 4. 4 plus 1, 5. 2n means 2 4s 8. C 4. That's it. You just need to do that. Good, good. Consider the 4 matrices with their dimensions 5 by 10, 10 by 3, 3 by 2, 12 by 5 respectively. The minimum number of scalar multiplications required by matrix chain multiplication algorithm equal to. See, for those who do not know matrix chain multiplication, here I am going to present a shortcut. Okay, use that to get the answer quickly. See, generally matrix chain multiplication, people do that all. See, if you want to directly solve this problem by considering all different possible orders, 4 matrices are there, 5 orderings you have to consider. For everything you have to use that method. By the time you complete, your examination will be over. Okay, so that is not a good idea. Of course, majority of the people do that method, but that is not advised. Okay, please note that. See here, this is the formula. The MIJ formula is given by, that is minimum number of multiplications required to multiply the matrices from MI to MJ is given by formula minimum of MIK or MIK minus 1 plus MK plus 1 J, or it's like MIK na, at K you cut MIK to MIK plus 1 to J, because K you cut I to K, K plus 1 to J, and number of multiplications required to multiply these two matrices, which is given by formula Ri minus 1 into Rk into Rj. So here K varies from I to J, where J is not included. That is the formula for, or the recurrence relation for finding minimum number of multiplication required to multiply matrices from MI to MJ. Okay, where K is the place where you cut the or divide that particular product, my dear friends. That is right. So here what we do is, whenever this problem is given, write down R naught, that is 5. So this 5 by 10 is there, no? So first one you call it as R dot R1. R1 is 10. See, the same 10 will be repeated. So this is R1, R2. R2 is 3. Yeah, I'm doing it. And 3 is there, then 12. Then 5. See, of course, shortcut in the sense, if you practice well, then you can do it faster, sir. Okay, but it's not like, you know, 1 word answer, 1 second answer. You have to do this particular work. Okay, then you can get this particular answer. Okay, see, because here we are going to first find the first diagonal values, second diagonal value, third diagonal value, fourth diagonal value. In that, mainly the work would be for these three fellows. Okay, and if you properly understand this procedure, then you can get that answers very quickly. And one point which we need to understand, first let me explain that, then I'll continue with the problem. Suppose, look at this. So here I am just doing it for you. Please see this carefully. Suppose you want, see this main diagonal you have to keep track of, sir. This main diagonal you have to keep track of. Then what you need to do is the following. Suppose, okay, you want to find this particular answer, sir. You want to find this particular answer. See, in the left side, you go up to main diagonal, that is this particular value. This has to be added with this value, that is the leftmost value is added with bottom value. Then this value to be added with this value. See, for every element which you want to find it, okay, what actually happens is Mij, okay, Mi to Mj you are multiplying. For example, it is M24. It is actually M24 you want to find it. See, when you want to find M24, you can cut at 2, that is M2, then M3, M4 is one side, then M3 you can cut it. That is where you cut, that depends. This particular tick mark correspond to when you cut at 2. This particular tick mark correspond to when you are cutting at 3. So those values are directly available in the table, my dear friends. So when you want to find a particular value, move left till the main diagonal. So the main diagonal fellow is added with the bottom fellow, and the next fellow is added with the next bottom fellow, next fellow added with the next bottom fellow. Like that you can easily solve. Okay. Now for example, if you want to find this value, if you want to find this particular value, the logic is very simple. Leftmost added with this fellow, next fellow is added with this fellow, next fellow is added with this fellow. So this values you add it, then corresponding Ri minus 1, Rk, Rj, that also can be understood properly if you practice well. That also I'll tell you quickly. So let us see all this quickly, my dear friends. So here first thing which we need to do is we have to find main diagonal. See, the main diagonal is very simple, sir. Here R0 to R4 values you are having now. First three values you multiply. See here in the top corner, first for main diagonal you can just write down 1 2 3 4, sir. Directly you can write down 1 2 3 4 main diagonal. Now what you need to do is R0 to R2, that is R0 to R4 values are given. First three R values you multiply, that is 5 into 10 into 3, that is 150. The next three R values, that is 10 into 3 into 12. First 3 you multiply, that is this value. Next 3 you multiply, that is 12 3 is 36 into 10, 360. Next 3 values you multiply, that is 12, okay, you can say 3 12 36, 36 5 is 180. What happened? 1 second. How you get 4 values here? Extra value you are getting. Okay, sorry, it is M11 means, sorry, it is first diagonal is 0, na? First diagonal is single matrix, you don't need any multiplication, sorry, not first diagonal, second diagonal onwards. First diagonal will be 0, sorry, second diagonal onwards. Because when you are having single matrix, how many multiplications you need? You don't need any multiplications. From here onwards, you require that. Okay, these values are first 3 R values you multiply, this is 150. Second 3 R values you multiply, that is 360. Next 3 R values you multiply, that is 180. Okay. Up to here it is direct, sir. Only the 3 values you have to calculate, my dear friends. Only the 3 values you have to calculate it. Because this particular diagonal, this is corresponding to, you know, I minus j is equal to 0, means there is only one matrix. I minus j is equal to 2 means what happens? Two matrices are there. Okay, two matrices, that is 1 2, difference is 1 means two matrices are there. In that sense you are going to consider. Am I clear? So this correspond to multiplication of single matrix. The next diagonal correspond to multiplication of two matrices. That is, if you are having m1 m2 m3 m4, we are multiplying m1 m2 m2 m3 m3 m4. Those are those numbers, my dear friends. Now next thing which we need to understand is the following. See, when you want to find this value, that is like m13. See, mainly you are going to find m13. The next one is m24, and final value which you are going to find is that m14. These are the three values we need to find, my dear friends. And for this, the idea is very simple. Let me introduce that particular idea quickly for you. So for m13, what we need to do is, I already mentioned, when you want to find this value, see the leftmost diagonal value, that to be added with this, that is 0 is added with 360. Then next value is added with next bottom fellow, that is 150 is added to 0. Now here when you are finding 13, no, let me clear this. See, remember this, when you are finding 13, always this 1 means R0 you are going to find. So here R0 and R3 will be fixed. The mid value will be, that is R0, R3 are fixed. The mid value is R1 and R2. So here 5 and 12 will be fixed. 5 and 12 will be fixed. The mid value is, once it is 10 and next time it is 3. Suppose if the first value is smaller, then k is 1 selected. Second value is smaller, then k2 selected. Based on that, we are going to take the values, my dear friends. Please note that. Now what is this value, sir? This is 150 plus, it is 180. So 330. It would be more than 330. So smaller will be, this is like, sorry, the 180 plus 150, 330 is smaller. This is the minimum. So k value which is selected is 2. Second value of k is selected, k is 2. So here it is 2 and this value is 330. Hope you understand. Is the idea clear? See, for using this method or for understanding it takes time, but once you understand, you can solve this problem very quickly, sir. Now next one, m24, if you want to find it. Same thing, m24 means travel to the left till the diagonal. Diagonal value is 0. So this value is 0. And bottom fellow you find out. That is, for this diagonal fellow and the bottom value. That is 0 plus 180. 0 plus 180. Then 360 plus 0. 360 plus 0. Now here, when it is 2 4 means R1 and R4 are fixed. That is, R1 and R4 are fixed this time. R1 is 10 and R4 is 5. These are fixed. The intermediate values will change. The intermediate value means k is equal to 2, k is equal to 3. You are going to consider. K is equal to 2 means 3, k is equal to 3 means 12. So if you select the first one, k value is 2. If you select the second one, k value will be 3. So obviously the first one will be smaller because it is 150 plus 180, 330 again. It is 330 again. So corresponding k value is 2. Corresponding k value is 2 because first value is selected, k is 2. If you selected second value, then k would be 3 because k is 3. I mean k is equal to 2 gives you minimum value for that m24. So you're going to select that. That is 330, my dear friends. That is 330, my dear friends. Now the final answer, same story. Here you're going to consider 0 with 330, 150 with 180 and 330 with 0. And here the values of R which you are going to consider, this is 1 means R0 and R4 are fixed. That is R0 means 5 and R4 is 5. These two are fixed. And corresponding K value, you can take K1, K2, yeah, K3. You have to identify which one is smaller, my dear friends. So obviously, this fellow will give you the smallest value. So it is like 330 plus 75, 5, 10, 405. So the answer is 405. And here you are going to take second one. You are taking see K 1 2 3. You are going to take second value of K means K is 2. So the answer for this problem is 405, my dear friends. So now if you want to get the shortcut for this, after getting this answer 150, 360, 180, the other answer will be definitely more than that. So in that minimum value is 150. Here you have 180 is there. Maybe here itself you can understand, maybe after this 330, 330, any value which you are going to get will be more than 330. So obviously 405 you can do it. Without completing the answer also, sometimes you can answer the question, sir. Of course, that is a different story. Okay. Without completely solving, because here for M13 and M23, M13 and M24, if you got 330, obviously the answer should be more than 330 only. Because minimum of those two values is 330. So that particular value has to be more than that only. So it cannot be 75, 180, 150. So definitely 405 is the answer. Like that you can identify, my difference. Babu, Sham Babu, is that clear? Any doubt? Okay. Nice. Super. Perfect. Perfect. Consider the product of matrices M1, M2, M3 having W rows, X columns and X rows, Y columns and Y rows and Z columns. Under what condition will it take less time to compute the product M1, M2, M3 than to compute M1, M2, M3? So here M1, M2, M3 matrices are given. M1 is of order W by X. M2 is of order X by Y. And M3 is of order Y by Z. Now he want this to take less time than M1, M2, M3. So let us write M1, M2, M3 should take less time than M1, M2, M3. So first of all, let us calculate these answers. What will be the answer for this? Let us see. If you want to multiply these two fellows, W by X and XY, X by Y, so you require WXY multiplication. Suppose if it is some intermediate, okay, I1, then you multiply these two to get the solution, my dear friends. So this is again M1 by M2 is nothing but it is W by Y matrix, that is multiplied with Y by Z, means you require WYZ multiplications. This requires WYZ multiplication. If I do by this order, M2, M3, it requires suppose some intermediate matrix, and the order of this would be X by Z, and this fellow require how many multiplications, sir? This fellow require XYZ multiplications, followed by this fellow, that is nothing but solution, which is of the order W by X by Z, which requires WXZ multiplications. So this order requires WXY plus WYZ multiplication, and this order require XYZ plus WXZ multiplications. Now what is that he is asking? He want M1 M2 multiplied with M3 should give you less answer. Okay, so what is that he is asking? Under what condition it takes will it takes less time to compute the product than to compute this one? So you want this value to be less than this. You want this value to be less than this, my dear friends. You can do one thing. You can divide throughout by WXYZ. Divide by WXYZ. So when you divide by WXYZ, it is 1 by Z, it is 1 by X, it is 1 by W, it is 1 by Y. So 1 by Z plus 1 by X is less than 1 by W plus 1 by Y. This is the condition to make the first order, okay, better than the second order. That is the story. And this is about a LCS problem, my dear friend, longest common subsequence problem. The idea of LCS is very simple. See, if you want LIJ, whenever, that is longest common subsequence for the first sequence is like 1 to I. It's like first sequence you are having you say X1 to I. Second sequence you are having Y1 to J. See, the condition here would be like that Xi and Yj may be matching with each other, or the other condition would be Xi and Yj are not matching with each other. These are matching means you already got one score. So once you got these two matching, you just need to consider the remaining problem. That is, you have to consider X1 to I minus 1 and Y1 to J minus 1 you have to consider. And that is nothing but, if it is Lij, if you call it as Lij, you call it, or Cij, what he called? Okay, you call it as Lij. So this problem would be Li minus 1, J minus 1, but you already got one matching score plus 1 you have to do it. That is when they match, the ith and jth index, xith and jth, yjth index matches. If they do not match, okay, so there are two possibilities. If you are having this 1 to I and y1 to j, or let us write this like this, I minus 1 I, j minus 1 j, again I write the same thing, 1 to I minus 1 j and y 1 to j minus 1 j. This is I, sir. This particular value is I. Now what happens? If they are not matching, xi and yj not matching, so this is useless. So you may consider this problem, or you may consider this problem. Whatever gives you maximum, that you have to consider. In this particular case, you are going to consider the maximum of Li minus 1j ya to Lij minus 1, my dear friends. And that is exactly what the solution for this problem. So when you have this Lij, actually the question was missing here. So Lij is equal to, he just asking what is expression 1 for xi is equal to yj. The expression 2 is when xi not equal to yj. Sorry, there was a printing mistake in the question. So obviously for expression 1, A is the correct answer. For expression 2, B is the correct answer. Actually it is MSQ. But in your Nielit examination, we don't have MSQ. So any one thing will be asked, my dear friends. So just go through that. Okay. So that is about this particular solution, my dear friends. Yeah, this particular problem for 01 knapsack problem, you can try this as homework. 01 knapsack problem is one of the interesting problem. If you can get the answer for this particular problem, okay, just write it in the chat box. The 01 knapsack problem. If you can't do it, next time you can ask me. I'll do it for you in the class. So that's all for today, my dear friends. Thank you for your time. So in the next class, that is day after tomorrow, I'm going to discuss the graph algorithms. I'm going to discuss. That is on 10th. Today is 8th night. On 10/5/23 at 10:15 p.m. Let us discuss what graph algorithms. Till that time, have a nice day. Thank you. That's all for today, sir.